Hello. Today we're going to be solving a math challenge using these numbers that you see on the screen here. What we're going to be doing is trying to solve all of these equations to make these statements being true. And what you have to do is add mathematical operators between the numbers on the left to make all of these equal 6. For example, we'll do an easy one. If I add a plus here and a plus here, 2 plus 2 plus 2 equals 6. Okay? So we're going to solve this for zeros, ones, twos, threes, fours, 5s, 6s, 7s, 8s, and 9s. I haven't drawn those numbers on here yet, but we'll get to those. So, and you can only use these mathematical operators shown in the box here. So we can use a plus, minus, multiply, divide, a square root, or any nth root, factorial, and parentheses. So we did this one. This one's pretty easy. So let's do this next one here. So with ones. So let's see. If I do 1 plus 1 plus 1, that's 3. But if I multiply anything by 1, it's just the same number. So I can't really use multiplication. So this is where I think we're going to end up using this factorial. So let's see, if we get 1 plus 1 plus 1, that's 3. Now, if I put parentheses around this, so I have the number 3 in the side of these parentheses. Now, if I add a factorial here, that's going to tell me to add all of the numbers that lead up to 3. So 1 plus 2 plus 3. Is what factorial would be for 3. So 3 factorial would actually be 6. So that's the solution to 1. Now let's do 3. So, okay, we have a student that would like to answer. What do you do for this one?
So you would multiply this, but then you would have to put minus 3 and that would equal 6.
Good job. Can you let the people see? So yeah, 3 times 3 is
9.
And then 9 minus 3 is
6.
Good job. All right.
I think
Can you solve 4?
Well, let's do it together.
Okay, what do you think?
So I'm kind of thinking the same way, but like it's not possible. Because if I use times...
Well, let's see, what happens if we do 4 plus 4? What's that equal?
4 plus 4 is 8.
So then we got 4 more. So how do we get, how can we get, so 8 is too much, is 2 too high, right? So we need to subtract 2. Is there any way we can turn 4 into 2?
4 into 2.
Anything over here that would make 4 turn into 2?
I don't even know what these
are. Well, you haven't got to this yet, but this is our solution right here. Now, if we take the square root of 4, it's going to do that little symbol. What that means is the square root. So what number multiplied by itself equals 4? If you took one number and multiplied that by that same number, it would equal 4. Do you know any numbers that does 1 times 1 equal 4?
Does 1 times 1 equal 4?
Does 2 times 2 equal 4?
No.
2? No? What's 2 times 2 equal?
4.
There you go. So actually the square root of 4 is 2. So square root of 4 makes this become 2. So we'll just write 2 underneath here. So now we have 2. So now we have 4 plus 4. So should we add 2?
No. We minus.
Minus. So minus the square root. So 4 plus 4 is 8 minus the square root of 4, which is 2, equals 6. So we've solved that one, that one, that one, that one, and now we have one more. So we have, this is another one where, I mean, you can't really do anything with 0, right? You can't multiply it, divide it, square root, everything's going to be 0. But there is one trick in our book. It's factorial.
What is factorial?
You haven't learned it yet, but this is going to help us solve this problem.
No.
0 factorial is actually equal to 1. So if I just make all of these 0 factorials, then we have 1, 1, 1.
So then we'll have to do the
And now it's the same as the problem down here, where we had 1.
I
So
can solve it.
What do we do now? Yep. Yep. Parentheses. Nope, it's gotta go on the outside of the factorial. There you go. And now that's 1 plus 1 plus 1 equals 3. Now what do we add to the outside of the parentheses?
Outside. Now it's...
Down here we had a factorial on the outside.
So we put a factorial on the outside?
Mm-hmm.
Now it's...
And now we have 3 factorial, which equals 6.
Now it's my turn to...
And then we have a couple more numbers to solve, so let's do that. Charlotte, how do you think we can add or do something with 5 to make it equal 6?
So, 5.
You figured this one out?
No, I have not. So, I'm thinking about using the plus sign between this. But
5 plus 5, that's going to be 10.
I know. But then 10, if you minus 5 from 10, that would be 5. But we just need one more than that. So we need to find a way to minus 4. So would we...
We want to add 1. So if we add 1 to 5, that would equal 6, right? So is there any way we can turn 2 5s into a 1?
Wait, yeah.
How?
Do we take this?
No. We don't. That would make it a huge number if we use factorial.
This? Wait, no.
What are numbers? What's something we can use to make things smaller?
Square root?
Yeah, that's one of them. Is there any other things that can make things smaller? Minus, yeah. So if we did that, 5 minus 5, that would be 0. So that would just be 5. So it doesn't get us what we want. What other things make things smaller?
Division?
Yeah. So what would that do?
Divide?
What if we divided? What's 5 divided by 5?
1.
1. Oh wait, that's what we needed. So that would make 1. So 5 divided by 5. You don't need a parentheses here because you always do parentheses and multiplication before addition. So 5 divided by 5 is 1. But I'm just showing you that this is 1.
Oh, I used
And 5 plus 1 equals 6.
I used this at school.
Yeah, parentheses are good. They help you learn. All right,
I've already learned that.
let's try 6 times 6. I mean 6, 6, 6, and another 6. So all 6s. How do we make this one work? Can you think of that?
I kind of want to use that same thing, but then this isn't one number more, so it's going to be hard.
Well, I think this one might be a little bit easier than we're thinking. I think we can focus on just these top 2. Just the plus and the minus. I think you can solve this one pretty simply. Try it out. Yep. 6 plus 6 minus 6. So these 2 cancel out. Just leaving the original 6. That one was easy. All right, 7. That's going to be tricky. How do we do that? Can you figure that one out?
Can we do the same thing? I'm thinking about this was very easy.
You're thinking about this one?
Yeah.
Oh, you might be right. So it's kind of similar because we're 1 away from 6. So instead of adding 1, we have to subtract 1. So if we take 7 and then just do 7 divided by 7 to get 1, is that a division? Yeah, so 7 divided by 7 is 1, and then 7 minus 1 is 6. Good job, you're smart, girl. Figured that out easily. All right, what about 8? Can you solve 8? This one's tricky.
We would need to minus 10. So if I did a plus sign here, that would equal 16. But all we need to do is minus that 10. How do we turn that into a 10? We need it more. Would you use that?
No, that's going to make it huge.
That's going to be like 81.
What about,
No, those go together. What about square root? Wait, no, that makes it tinier.
okay, well, here's a little trick I need to tell you about. There's more than just the square root. You can do a cubed root.
What the heck is that?
You can do the cubed root, which would make a 3 here. So it'd be so if you do a cubed root of a number, that means if you multiply that number by
How
itself,
do you draw a cubed root? Like this?
like this, you would do 3 and then the number. So what that means is that if you take the same number and multiply it by itself 3 times, it will equal that number. So can you think of any numbers that if you multiply it by itself 3 times in a row, it would equal 8?
What?
So here, so 1 times 1 times 1. So that equals 1. So that the cubed root would be 1. Now if we did 2, we do 2 times 2 times 2. So 2 times 2 is
4.
4, and then 4 times 2 is
4 times 2, 4 times 2 is 8.
8. So actually, the cubed root of 8 is 2. So now we can actually go back to the one we did earlier, and if we take a cubed root of all these 8s, cubed root of 8, cubed root of 8, cubed root of 8, so that would turn all these 8s into 2s. So now we have 3 2s here. Now can you solve that one?
Yep.
What do you do with that?
So,
Yeah, so cubed root of 8 plus cubed root of 8 plus cubed root of 8. That equals 6. We got it. All right, now there's one more.
This-
9s, all 9s. How do we solve the 9s?
kind of easy. So 9 plus 9 is 18, right?
Yeah.
So we need to, first, like we always said, we need to find the one that we use.
Mm-hmm.
Are we going to use the plus sign?
Yeah, we will. I think we will.
Minus?
Actually, I don't know. I don't know if we're going to use it or not. We have to think about, I don't know if we're going to use the plus or the minus, to be honest. But let's think about this for a second. You're blocking the numbers here. Does 9 have any special properties?
What do you mean by that?
Like 8 had special properties because it was the cubed 2, it was the cubed root of 2 equaled 8. Or 8, the cubed root of 8 was 2.
Wait, why don't I use cube
So-
right here?
But 9, what I'm getting at is we can do the square root of 9. So we can do 2 numbers multiplied by them together to make 9. What number would that be? Can you think of any numbers that make 9 multiplied by each other? 2 times 2 is 8.
3.
3 times 3 is 9. So now we can do the square root. So we just do that. And now these are all 3s. Okay, now can you solve it? Because we did 3s earlier. You should be able to do that. 3 plus 3 is 6.
6. But then, what are we going to do with that?
No, we did something else.
What?
I think this was a multiply situation. 3 times 3.
Oh, yeah, because that equals. We put that multiply right here, and then minus 3
Yep.
equals 6.
3 times 3 is 9, minus 3 is 6. So to be clear, we got the square root of 9 times the square root of 9 minus the square root of 9. So we've now solved all of these problems, making 6, just using these standard mathematical operators. I think we're going to stop there. All right, thank you for watching.
Yeah.